Okay, we will wait for another 5 minutes and then we will get started. Uh, we will start at 5 minutes past 5. We will just give another 4 minutes for others to join in. We've got a lot to cover, so uh, just another 4 minutes to go. Okay, we will get started. Before we continue, can I know how many students are attending this from the ICT video conference room on Lodha campus? Anyone at all in the ICT video conference room in Lodha campus? Probably no one, because no response. Is there anyone attending from the postgraduate lab in Lotoka campus? Probably no one as well. Anyway, I mean, so we've got 21 participants that have joined at the moment. So I've got a lot to cover, and I've got a few things to say about your assessment. So we will get started without wasting any time. Before I continue, are all of you able to hear me well, or is it too loud, or is there any echo?
Yeah, it's working. There's no echo from my side.
All good.
Anyone else?
All good.
One more.
All good.
All right, let's get going then. Can all of you see my PowerPoint slide?
Yes.
Yes, sir.
All right, that's good. So today's lecture is on fog computing, but before I start talking about fog computing, who has just joined, please mute your microphone. Someone that has just joined, please mute your microphone. Okay. Funaki Tofa, please mute your microphone. Okay, so let's get going on to the next slide. Any questions from the last lecture that we had? Basically, the last lecture was you guys contributing about what you had researched and what you had prepared and shared from on mobile cloud computing. So we all good there? Assuming a yes. Silence
Yes, sir.
means yes for us. How are you getting along with the labs on XML, HTML? Any issues there?
No, sir.
Okay. And I'm sure you have a lot of questions about the research paper because the proposal is due tomorrow. But before I let you ask the questions, I want to show you a few slides about the research paper, which might answer a lot of your questions. Any questions about the XML project? Again, I'm going to show you one slide about the XML project, and after that you can, if there is any question, you can ask. Okay, so we are going to have classes during the mid-semester break. We have started 2 weeks late, and having classes during mid-semester break will enable us to catch up 1 week. And the other week that I would like to catch up is when I'm on campus, and I will inform you later which week that will be. So in one of the weeks, we will develop with the lectures and classes. Apart from that, just because at the moment this course is being conducted online, I don't see students should be having any excuses about not being able to attend. You have the freedom to attend this course from wherever you are. If you are traveling, if you are sick or whatever, the way we are offering the course at the moment is quite flexible. So I expect total attendance from all of you. And I'm going to bring up some information about requirements of being an active student in this course, and what I'm going to do if you are not active. I'm going to go over the assessments in the next slides and talk about them in detail, and probably I will do that for the last time because we have gone into 4 weeks of the course. That is almost like 30% of the course. Research paper proposals are due tomorrow. Email it to me. And I have also requested information so that once I'm there in Onlogala campus, I have a number of projects that are going on, and I would like to conduct research, and that information will tell me that where you are working and what type of information or data I can get from you. Okay, let me see who is not mute. Jobe Tamata and Faria Tafsil, please mute your microphone. Fariha Tafsil, please mute your microphone. Okay, so all good now. So what I'm trying to do is, apart from being able to know where you are placed and what type of information and data I can get from you, I'm trying to build my research network as well as my friend network, because at the moment I really do not have any friends and families left in Fiji. They have all migrated, and I did migrate with them as well. But I'm coming back, so it's time to make new friends. That is one of the reasons why I'm asking you to call me Sam. Okay, so let's get going. This is what your course assessment looks like. Assignment 1 is on is where you are going to build an XML prototype of a business application from the topics provided. You will write a report that will be worth 15% and presentation 5%. I'll have to rush through this. We don't have much time. There's going to be a mid-semester test in week 10, or it might change, but I'll keep you informed. Assignment 2, the major assessment, 30% of the course, almost 1/3 of the entire course, research paper and research paper presentation, research presentation. And final examination, 40%. So to be an active student, I've already spoken about this, that your excuses, the excuses that you are giving at the moment really doesn't make sense and is not relevant, because what is stopping you from attending online? You are traveling, you are the only thing, probably the only constraint at the moment would be not being able to connect. So in short, there is no excuse for not attending this course at the moment, because the mode in which it is conducted. So if you have not already done, and if this is your first session, suddenly you've woken up from your slumber and realized that, oh my God, this semester I'm doing IS413, Advances in ICT course, and I haven't started. So this is for you. You need to assess your course model page and check the resources that have been placed there. And you know that as your course coordinator, I'm able to check when was the last time you accessed your course module page. You need to select a research topic and submit a proposal. You need to select a topic for assignment 1 and email the topic to me. Attend online lectures from 5 p.m. on, sorry, you guys are Thursdays. See, this is what happens when you teach more than one course. Can you still see my PowerPoint slides?
Yes.
Yes, sir.
Okay.
So
Alright.
just a question.
Yeah.
Select the topic for assignment 1.
Yeah.
Isn't that an XML project?
Yes.
Okay, for the e-commerce one.
Yeah. So you know the topics that you can select there is like online ticketing, online booking,
Yeah.
bookstore. Got it?
Understood, sir.
Yeah. And participate in lecture activities and tutorials. So I think last week those that have been inactive must have received an email from me, and your names have been passed on to the head of school and has been recorded. And the head of school has told me that if I continue finding students being inactive, I will be able to withdraw them from the course. So I do not want to do that because we are friends, but please do not abuse my friendship. Any questions or clarifications about what I have just said? None? That is good. Right. I want to talk about communicating with me. You can already see that I am so overwhelmed that I'm mixing things up. Sometimes in my Tuesday class, I talk about assessments for IS413. And sometimes on my Thursday class, I talk about assessments for IS433. So please send emails to me directly if you have any issue with the course. And it is very important that you include your course code as the first word of the subject of your email to me. And your subject should be descriptive of the content. So if you send me emails that do not comply with the above, you will not get a response. And you might say that I'm being nasty. Yes, I am. But come on, you guys are adults. You are postgraduate students. Most of you are employed. You should be able to follow this simple instruction. Do not send me messages through your course Moodle page. I have noticed that all of a sudden some of the students have woken up and sending messages, say what is going on, what can I do, where is this, where can I find the research topic? Come on. Haven't I been chirping about this for the last 4 weeks? And also avoid asking anything that has already been specified. For example, it is specified that the research paper, you can do it individually or in groups of 2 or 3. Do not ask me if you can do in groups of 4. And do not send me an email asking me, say, is the Internet of Things topic still available? You go and check. The topic that has been taken is listed on your course Moodle page, and it will indicate there whether this topic has been taken or not. Sometimes, I exchange 5 or 6 emails with you, just trying to understand which course you are doing and just trying to give you information that I have already talked about in the lecture and I have already provided on your course Moodle page. So, yep. what can I do? I have been a student as well, and that's what students are like. But anyway, if I can make a few changes, it will be better if you go to your for your next course and for your further education. Any questions, clarification, or comments over here? Okay, so let's talk about your assessments on the research paper. I've got 2-3 slides on this, and I'll present a number of information. You, Sivanesh, please mute your microphone. And I'm going to present a number of information about this, and then I will stop and I will let you ask me questions in regards to this. So please, I'm expecting you to be sitting in front of your computers with a notepad and jotting down things, because though this video, this lecture is being recorded, but the recordings are not being made available immediately. And because these recording files are very large, it takes Center for Flexible Learning a number of days to give it to me. And just because I want to make it one Play Store, that's why I post it on YouTube. So this research paper should be done individually or in a group of 2 or 3. Select a research topic, and most of you have, thank you, and email it to me. Research proposal is due tomorrow before 4 p.m. and you will email it to me. The proposal should be formatted using Times New Roman 12-point font, single space, and should be minimum 2 pages and maximum 4 pages. Hold on, someone is chatting with me. Please, if you have microphone, speak whatever you want to say. The proposal needs to use or have 10 journal articles referenced. A number of students emailed me over the last 2-3 days, and I realized that they were the ones working on the proposal because they had not started earlier. And they asked me how many journal articles is needed for the proposal part of this assessment. And for goodness sake, please stop chatting at the moment. I will stop and you will get a chance to ask questions. 10 journal articles referenced. And the other thing is, I'm not sure. I am under the assumption that I do not know how USP operates at the moment, but I'm under the assumption that one of the first courses you do is a course on research methods. Is that correct? Before you get into the postgraduate class or postgraduate courses? Or am I wrong? Or maybe, I'm not sure how it works down there at USP, because what I thought is that if you are enrolling in a master's program or a master's course, you will be required to do a research methods course before you continue. Is that correct?
That is correct, but it's not provided at USP.
Really?
Because I remember when we enrolled in the PG unit, there wasn't any unit for that particular research paper writing or something.
I mean, I'm an ex-student of USP, and I remember doing a research course that was not provided by SIMS, School of Computing Information and Mathematical Sciences. It was, I think, provided by what is now known as Faculty of Business and Economics, and it was called DG400. So, okay. I mean, so we are going to work on the premise that you do not have. Have you written research papers for any previous courses?
Yes, we have.
Okay. And who was that? Was that Safia?
This is Rukshar.
Rukshar, yeah. Oh, Rukshar, of course, you have written because your research proposal is almost perfect. But what about the other students? Have you written a research proposal and research papers before, or is this like your, I'm sure this is not your first postgraduate course, it is happening in the second semester?
I think not everybody has the exposure, sir.
Not everyone has the exposure. So this is a mixed bag of things. Some of them are experts, some of them are beginners, some of them are somewhere in between.
Yes, sir.
Okay, it is not a problem. I'm going to guide you through this. I mean, over the years while teaching here and there, I have guided a lot of masters and PhD students just on a voluntary basis. So why not you guys? So going back to whatever I was saying was that in your research paper, you must either use a hypothesis, a theory, a model, or a framework to validate your research findings and compare research with others. Because when you are writing the research proposal and when you are doing a literature review, you would see that the other researchers, the other authors, the other papers are already using such things. And they have already used a theory or a model or a framework to validate the research findings and verify the findings. And once you do that, you have a high quality research paper, and the chances of your paper being accepted and getting published is really high. Hypothesis is fine, but hypothesis is just asking a question or proving or disproving hypothesis. It is fine, but it is lower quality. But when there is a combination of both, then it is really good. I'm going to talk more about that on the next slide. But before I move on, let me give you an example. For example, if you are going to do research on, or if you've decided to do research on e-commerce or e-business, adoption of mobile cloud computing in Fiji and the Pacific Islands, adoption of cloud computing by businesses in Fiji and the Pacific Islands, usage of e-commerce, usage of educational technologies like Moodle and others. One of the theories and one of the models that is being used is called, for adoption of technology, it is called the technology acceptance model. And this model is very widely used by all researchers that study this phenomenon. The other one is called UTOT, Universal Theory of Acceptance and Use of Technology, UTAUT, Universal Theory of Acceptance and Use of Technology. So if you use such things to validate your research findings, it becomes very easier, and then it becomes very easy to write your results and to conclude and everything. And you need to go and find a paper like this, similar to the topic that you are working on, and look at what they have used. Hypothesis is fine, but hypothesis makes this paper very simple. And remember, we are not writing an essay. We are not writing a newspaper column. we are writing a research paper. So I'm going to talk about hypotheses, theories, models, and frameworks. And I've got 2 more slides to go before I stop and take your questions. So why do we have to use them? Simply to validate the findings of our research. Otherwise, we can just write an essay and no one will believe us. No one will use our published paper. No one will cite us because we did not validate our findings. It is very easy if you are on the other side of the spectrum. For example, if you are a science student or computer science student or writing research papers on chemistry, physics, or biology, you will just run experiments, you will do observations, and you will write it down. Or you will run computer algorithms, simulations, observe, record outputs, report, and bam, your paper is done. But for information systems, we align towards the social science paradigm. And at the moment, I don't think we are at that level where we can go and actually, within the scope of this course, we cannot go and develop an e-commerce website and put it out there in the public and see what is happening and what is not, and then wrap things up and report. So what we are going to do mostly for this course, or within the scope of this course in the next 10 weeks that you have got, is we are going to do what is called desktop research. Desktop research simply means you sit at your desk, use your computer, look for papers, look for information, find data that is available, find what has been done. And this is what I would suggest. I mean, if, for example, someone has already looked at the adoption of educational technology in New Zealand, as a researcher, you do not have to reinvent the wheel. What you do is look at the research instruments he or she has used, look at the research methods he or she has used, look at the surveys, questionnaire he or she has used. If you are happy, ask for permission. Always you will find an email address of the author in the paper. Ask for permission and reuse it, and you are done. As simple as that. Okay? So this is what I'm suggesting, although those of you that are experienced and have done this before, you have your own way of doing things, but this is for students at the moment that would probably like some guidance. So once you have selected your topic, you will have to decide what type of data you are going to collect and how the data will be collected. For example, some of you are wanting to do surveys under the topic educational technology in regards to the use of Moodle by USP students. Sounds good. But what data are you going to collect? What are you going to ask the students? And the other thing is, again, probably this is not within the scope of this course and this research paper. Most of the time when we create surveys and we interview or collect information from human participants, that questionnaire needs to have an research ethics committee's approval. So there's a number of things going on here. So what we will do is we'll try to keep it as simple as possible, and wherever possible, we'll try to just replicate research that has been done, research that has been carried out, or I'm sure we can get enough data at the moment. When it comes to data, when it comes to for information, Google is our best friend. So once you have decided what type of data you are going to collect, if you are going to collect text data, you'll be doing qualitative research methods, and your reporting of results would be different. If you are going to collect numerical data, you will be using quantitative research methods, and your reporting of data will be different. Again, you talk about statistics, you'll talk about probabilities, you'll use a lot of numerical analysis. And with text data, you will use a lot of qualitative analysis, or you can use a mixture of both. Once you have done step number one and once you have decided on step number one and step number two, the next stage is step number three. What hypothesis are you going to use to prove or disprove your research question? Remember, why are we doing the research? We are trying to solve a problem. We are trying to find a solution. We are trying to add knowledge, new knowledge, to the existing body of knowledge. Or we have some idea, which is good, but it has to be validated. And then you use a theory, you use a model, or use a theoretical framework, or use a conceptual framework. So this is what I've got, and what I would recommend that you use for the moment. As I told you earlier, that when I get on campus, I'm going to conduct a seminar on how to conduct research and how to write research papers. And this seminar would be for the entire school of Computing, Information, and Mathematical Sciences. And I will tell you the date on which I'm going to conduct that as soon as maybe 1 or 2 weeks as I arrive on campus, and I would like all of you students to attend. And listening to you and finding out that there is no research course available at the School of Computing and Information Sciences, probably one of my suggestions would be to the head of school and dean of faculty that I create a course and conduct a course. So for the moment, use this flowchart. Okay. So you ask the question, what I'm going to study, what your research question will be, and there you can get your problem, concepts, definitions, and areas for further research. And then you look at what has been done, what have others done on the same topic. That's where literature review comes on, and that's where you can find what theories they have used, what models they have used, and what else they have done, and how they have reported their findings. And thus, writing research papers becomes very easy. It's just like copying what others have done, but your results will be different because your data is different. You are collecting data from within a new context, from a new population, from a totally new demographics, business environment, external environment, and everything else. And then you will understand, okay, which theory can you apply? Which framework can you use? What conceptual model you can use? And then you get your data, and you formulate your results, and you report on the findings. And the methods, again, check what others have done. Okay, so this is your research paper proposal. This was already part of the research paper assignment that I gave you. And now let me stop for questions, clarification, or comments. Please say your name and say your question. Okay, I'm surprised that there's no questions. Is there a question in the chat? As I said earlier, I would prefer that You speak your question. Don't be shy. You are adults. You are not in primary school. Okay.
Madam.
All right, Melvin, you are the only one in the video conferencing room attending from there. That's good. All good, all good. Really?
Sir Melvin,
Yes, Melvin.
is it necessary for us to consider 10 journal articles? Could the numbers
For your
be?
proposal, yes. Is this, are you finding this out today?
This is the first lecture I'm attending, sir. I was away.
Oh, dear, oh, dear. And for the rest of you, if you have already written your proposal, how many journal articles have you referenced?
This is Rukshar. I think we did around 15 so far.
Okay, Rukshar, yeah. Anyone else?
So it's Sunit here.
Yeah.
I did 8 in mine.
Okay, so by tomorrow you should be able to get 2 more.
Yep. Okay, so I'll resubmit.
Okay, you've submitted it.
Yep.
Yeah, I've been very busy. You know, I've not been checking my emails.
Okay.
Anyone else?
Sir, this is Rukshar again.
Yeah.
Just a clarity. I don't know if any research method was introduced for the undergraduate program since I didn't study. So I think it would be better if you can ask the students so they can answer you. But I know that in masters or for PG level, if you're doing by coursework, I haven't done any units that were offered.
Okay, okay, all right. I mean, it is not a problem. Those of you that have already communicated with me or are sending me emails, you will see that I have been, I hope, this is again my opinion, this is again my perception. I will need to ascertain it through your feedback, that I've been able to provide you the information that you needed or clarification that you wanted, and I've been able to, I would say, ably assist you through emails and answer questions and point you in the right direction. So it is not a problem, not a problem at all. I feel that it is one of my teaching duties to assist you and to teach you how to write research papers. So do not worry about that. Any doubts, any clarifications, any questions, you can ask me now or you can send me emails. Okay, good. I've just received a chat message from Anil, who does not have a microphone, and he says that for those students wishing to enter into the master's program, master's by thesis, there is a research method course called SC400. Well, that's good news. I don't have to reinvent the wheel. Just getting some perspectives of what students I have in this course. So, as I understand, most of you are enrolled in a postgraduate diploma in information systems.
Sir, that thesis one is provided, but those who are doing masters by coursework, we do not have any research method class for that.
Yeah, because you will just do courses and you will get a master's, isn't it?
Yes.
You do not have to write a thesis.
Yes, exactly. That's the point.
Yeah, that is the situation. So thank you, Anil, for that, and no problem at all. So since there is no other questions, we'll continue. Assignment 1, some of you have picked up topics. The others, please pick up a topic and email it to me. And start doing your labs and working on this assignment. You can do it. You have to do it in a group of 2. There's going to be a mid-semester test, and there's going to be a final examination. Right. So probably this is the last time I'm touching on assessments, and after that I will let you fly independently and not bother you anymore, because you must be getting bored of me talking about assessments week in and week out. Any questions? All right, moving on. Course materials and resources on Moodle. At the moment, I have not placed anything on your course Moodle page yet. Oh yes, I did place some resources on fog computing, some papers on fog computing. I did. Okay, so what I want you to do is look at those papers, browse through them, and if your research topic is on fog computing, so there is a start. Apart from the fog computing papers that I have placed under week 4, I have not placed any lectures or tutorials yet, and I will place it later. One of the reasons why I don't place it earlier is because once it goes there, then you people don't want to attend lectures, and then I miss you. I feel very miserable. I'm only thinking about myself. Okay, so and on a regular basis, mostly on Mondays, I update the research topics that have been taken, the XML prototype topics that have been taken. Most of you have selected a research topic for a research paper, and it has been assigned to you. So that is good. Continue with whatever you are doing. Hold on, there's someone. Okay. Kunal, your microphone is also having some issues. Hold on. Again, there is a question from Kunal, and probably this is applicable or valid question for all of you. What Kunal is asking is that is it required to have some data for the first assignment, that is XML prototype? Basically, this XML prototype will be a demo of whatever you are trying to do. For example, if you are building, developing XML prototypes for a online train booking system or online movie ticketing system and things like that, then what you can do is you don't have to create a database. You don't have to go to as deep as that. What you can do is use data or read data from within your codes and just give a demo of it. Okay, you are building a prototype. You are just giving us a demo. So yes, the data can come through the application. You do not have to access the database, but you have to show pages where a user clicks on this, or if the user is required to create an account, the web page should show a login form to create the account, or if the user has already created an account, the web page should show login or create account. Then it goes, when it clicks OK, it goes to the next page. In terms of movie tickets, buying movie tickets online, so you should be able to select the movie, select the movie showing time, select the hall or the cinema in which the movie is playing, and you should be able to select a number of seats. Okay. This again does not have to be real. It has to be a demo, and it is only a prototype. So have I answered your question, Kunal? Okay. The other question is from Anil, and Anil is asking, will the proposal be graded? No, the proposal will not be graded, but your proposal will go towards your final research paper. So if you do not pass the proposal stage, if you do not get approval to advance from the proposal stage to start actually writing the research paper, so your 30% of the course is gone. So I hope I have answered your question, Anil. And sorry about that, Anil and Kunal. Since you are not able to speak, you're having issues with your microphone, you can always write your questions on the chat. Okay. I've already communicated about this student information that I'm collecting and keeping it for research and network purposes, and the information that you give will be kept strictly confidential. And the other thing is, do give me your personal email address, because what happens is when this course ends, probably you will not do a course with me again. I'm not sure about that, because I'm not sure about the next courses that I'm going to teach. But you know what will happen is you will submit your research paper to me for grading towards IS413 course. And after that, what we are going to do is I've got a number of colleagues which I will assign to you only for research papers that I feel can go for publication. So I've got a number of professors working with me in about 26 different countries. And we have this research network. So what I'm going to do is I'm going to ask one of these professors to assist you and edit your paper and enhance your paper and modify it so that it gets published in a ranked and indexed journal. So that is one of the reasons why I will need all this information. Okay. Right. Any questions or clarifications before we go on to the topic for the day? Okay. I'm going to stop there and I'm going to take a break because I need to go and get some water. And you guys can have 5 minutes break as well. I'm assuming that it is, not assuming, it is 5 minutes to 6 over there. We'll start at 6. And I think today we can finish a bit early. So see you in 5.
Bye. Going? Oh, lucky you.
Really? Someone leaving the course and going home? I heard that. ahead with and start looking at fog computing? Can all of you still hear me?
Yes.
Yes.
And can all of you still see my PowerPoint slides?
Yes, sir.
Yes, sir.
Okay. All right. Yep. All right. All right. There are still some people whose microphone is not mute, and we have been hearing all these weird sounds. Vigneshwar, Chris, please mute your microphone. Vigneshwar and Chris, please mute your microphone. Okay, so what we are going to look at today is fog computing, and you will see that hold on. Shalmendra, Vigneshwar, and Chris, mute your microphone, please. Okay, looks good now. Looks good now. All right. So you would have seen that we started with the cloud computing, and then we looked at mobile cloud computing, and now we are looking at fog computing. And today you will also come across terms like edge computing, mist computing, cloudlets, and mobile computing. So you see what has happened over the years, the way we have been doing things have made a complete 360-degree turn. So when we started with computing, everything was centralized. All the processing was done in the headquarters. The headquarters used to control everything, the servers, the data centers, and everything was based there. So what we were doing was centralized computing. And then as we moved along, we started to decentralize. We started distributing our computing power and computing resources to different geographical locations. And one of the reasons that we did this was because of the internet technology, because now the internet technology enabled us to compute from wherever we were. And then when the mobile era came in, smartphones, personal digital assistants, tablets, and other mobile devices came in and became prevalent, and we stopped using desktops and laptops, there was a need to centralize again. And this centralization was enabled with cloud computing, because what we needed was just a connection device to be able to connect to the cloud computing service provider. And this service provider would provide us with the resources that we need. If we wanted the processing power, it will come from there. If we wanted the storage capacity, it will come from the cloud. If you want the databases, communication, network, infrastructure, platform, software, whatever we wanted would come from the cloud. However, the problem was with the connectivity and latency, because to send our processors to the cloud and get the results back would take time, because we have no idea where our cloud is. For example, if you are using Google Docs, Gmail, and anything to do with Google, then your cloud is somewhere in the US, one of Google's data centers. Okay. Or for example, when I'm accessing something from USB's course Moodle page, my cloud is based near you guys on Lodala campus. So likewise, to be able to access or request services from the cloud and to actually get it on your device or on your laptop took time. And sometimes when the connectivity was not good, either you were not able to access, or it took a very, very long time. And what we call is that the website is buffering, or the website is, what was this? No, was the word hashing? No, that we used to apply to hard disk. Anyway, so to encounter that problem of latency, as you can see on this very first slide, researchers and the industry came up with the idea, why don't we do some processing on the edge of the network rather than taking it right up to cloud? And this is like, you know, if you have been using, or if you know about what a cache is in terms of memory, in terms of internet web pages, and mostly in terms of RAM memory. What a cache is that you frequently, when it comes to websites, your frequently used pages are cached within your browser. So whenever you want to visit them, you don't go and get your Google page right from United States. You get it from your browser because it is cached. And time and again, it gets refreshed. The same thing with the computers when they are processing, and in terms of memory, your frequently used programs are in the cache, okay? Because it takes time to retrieve it from the hard disk and load it onto the screen. So fog has a similar concept. Your processing will take place at the edge of your network rather than right up in the cloud. So what is the edge of your network? If you are using computers and PCs on Lodala campus, so the USB network, the USB gateway is, for example, the edge of your network. And whatever processing can be done there will be done there. If you are at home, your router, your modem, or your nearest ISP point, which is a tower or whatever is out there, is your edge of network point. And therefore, with this concept, with introduction of such technologies in processing, it became easier, and the latency issues were not there anymore. So moving on to the next slide. This is what we are going to look at today. What is fog computing? We will also talk about edge computing. We will also talk about mist computing. Okay, some of you might have not heard about them. We will talk about cloudlets, mobile computing, everyone knows, because we all have a mobile phone. We will look at characteristics of fog computing and why. I have already explained to some extent why, because we want processing to be done faster and nearer to the edge of our network or devices rather than going right up in the cloud. We will look at the fog computing platform, fog computing players, and what is the difference, pros and cons, advantages and disadvantages, and the major differences between fog computing and cloud computing, fog computing and edge computing, fog computing and mobile computing. Okay, so looking at fog computing, it is just an extension of the cloud computing paradigm nearer to the user. Okay, that's all. Let's say it's just like an intermediary. Okay, and therefore the processing power, capacity, and capabilities, efficiency, productivity of the cloud cannot be expected at the fog level. Okay, because there are limitations, and there are again limitations of the resources out there. But what it does is it just pushes the cloud nearer to the users, and this enables new applications and services. So I've already spoken about this. Cloud computing has latency issues, and sometimes because of that, we are not able to get the service at all, or it takes a very long time. Now, why has it been, or why is it called fog computing? That's quite interesting as well. The metaphor fog comes from the meteorological term for a cloud close to the ground. Okay, so if you look at the cloud, it's right up in the sky. But if you go to a high mountain, you will see fog over there, right? So it is between the cloud and the human beings, the fog. Just as fog concentrates on the edge of the network, the term is often associated with Cisco, the company's product line manager, who have coined the term. Okay, now would be the right time to tell you about edge computing, which is again an extension of fog computing, but this time not to the edge of the network, but right onto the mobile devices. Edge computing, also known as the edge, brings processing close to the data source, and it does not need to be sent to remote cloud or other centralized systems for processing. So you see, processing is done in the cloud, and you can push it further towards the user. You can process it in the fog, and then you can even push it further to the edge of the user's devices. So what is happening here is that like 5 or 10 of us are in the same room. We all have a mobile device, and we can all be sort of pooling our resources together and getting our processing done within that room. By eliminating the distance and time it takes to send data to centralized sources, we can improve the speed and performance of data transport, as well as devices and applications on the edge. So with the edge computing, what we are basically doing is rather than going to the fog, we are just computing at the edge. And so many people argue, or many people say, what is then the difference between edge computing and fog computing? The difference comes in where the actual processing takes place. As I said, fog computing takes place at the edge of the network, and edge computing takes place very near to the network or near to the devices. So, for example, if I'm using a device in my office, my fog computing would be the edge of my network on campus. If I'm using my mobile device with edge computing, my processing will be done within this room or within my office premises or within my building. With edge compute, With edge computing, compute and storage systems reside at the edge as well, as close as possible to the component or device or application of human that produces the data being processed. And therefore, just because we are not connecting long distance, we are not processing long distance, it becomes better than cloud and better than fog. Much better than cloud and better than fog. However, what we must realize is that as we get nearer to our devices, and if we stop and look at our devices, how powerful is our device? How powerful is our mobile phone? How powerful is our smartphones or tablets or PDAs? How powerful is that? So as we get nearer to the device, our processing capability and all other capabilities weakens, but the speed becomes faster. And nowadays what happens is with both the edge computing and fog computing, we are able to pool our resources together and form a virtualized network with the pooled resources. And that sort of gives us some strong processing capability. Moving on, now mist computing and cloud computing. So you must have heard, and when you first heard the word fog computing, you would have deduced the English meaning of the word fog, right? And usually you find the fog up in the mountains. And then comes mist. On a cold day, you will find mist at your level. That is on the road or near the trees, near your house or in a park. So with mist, we are right, not even on the edge, we are inside the mobile device. National Institute of Standards and Technology, USA, defines mist computing as a lightweight and rudimentary form of fog computing that resides at the edge of the network, bringing the fog computing layer closer to the smart end devices. So here the processing takes place on the PLCs that you have, programming logic controllers, on your appliances, on your devices, on your phones, or whatever you have connected. And this is most applicable when used with the Internet of Things, because with Internet of Things, we have number of embedded systems. For example, our refrigerator, our door locking system, our television, heating system, air conditioning system, watering system, or whatever system you have, all have embedded PLCs, programmable logic controllers, that is able to process within the device and is able to connect to the mist computing level. And then you would also hear about cloudlet, a new architectural element that arises from the convergence of mobile computing, Internet of Things, and cloud computing. It represents the middle tier of the three-tier hierarchy. So right on top, up in the sky, literally, not literally, figuratively, you have the cloud. And right in your hand, on the ground, you have your mobile device. And between that, what you have is your internet device. And thus you form a cloudlet. If you can see in the graphic around there, that That small coffee shop has formed a cloudlet that is connecting to the public cloud. Okay, so it is basically within the three-tier hierarchy from mobile, Internet of Things, and cloud computing. You form the middle one becomes a cloudlet. And finally, we look at mobile computing, which is nothing new because most of us have smartphones, most of us have mobile phones, most of us have mobile devices that is able to compute, store, access the internet. Mobile computing is also known as nomadic computing because we are able to take our computing resources with us wherever we go. Most of the time, these computing resources are effective, are available, and we are able to use them only if we are connected to a cloud computing service provider. Or in other words, in layman's term, we say that we are connected to the internet or we are connected to the network. Most of the time we say, are you connected to the internet? Or then you can do this, then you can do that. Applications, communication apps like WhatsApp, Viber, and other apps like Messenger, Facebook, other social media applications all require you to be connected to your internet service provider before you can use those resources. So it's basically computing on the move, computing on the go, or being able to compute on your mobile device from wherever you are. What are the defining characteristics of fog computing? The main one, low latency and location awareness. That means your processing cannot be delayed by, let's say, more than 1 microsecond or 5 microseconds. In location awareness, the device needs to know the location in which it is. Google Maps is a good example of that, and there are many other location devices. For example, there's an app called Foursquare that if you are in a particular area and your friends are in a particular area, it will inform you that your friends are around, and so forth. Wide geographical distribution, mobility, very large number of nodes so that you are able to find a fog node and able to do fog computing wherever you are. Mostly wireless. This technology is based on wireless access. Streaming and real-time applications, because yes, you want to be able to stream live events, watch live soccer, rugby, or watch live events, and being able to stream real time. And then it comes in fog computing can take many forms. For example, be used within Internet of Things, or be used with mobile cloud computing, or be used within the context of educational technology, or be used within the context of disaster management, social media. All these are good examples of fog computing. So why do we use fog computing and what is the reason? Basically, cloud computing is really good enough for everything, but the only problem is latency. to be able to use cloud computing, and cloud computing has really changed the IT infrastructure and the way we compute, because we have had freedom. We have been released from being confined to go to our office, to go to our computer labs, and be only able to compute from there, be only able to access internet from there, and be only able to use computing resources from there. Cloud computing has provided so much flexibility, so much scalability, and so much more, especially in terms of delivering services to our smartphones. And nowadays, we are able to do almost anything from our smartphones. But it has latency problem for sensitive applications, for applications that need real-time data, for applications that need the real-time streaming, for applications that need real-time connection and time-sensitive information and applications as well. So what fog computing does, it pushes the processing and the computing requirements to the edge, and we are able to compute from there. However, whether it is fog computing, edge computing, mist computing, cloudlets, or mobile cloud or mobile computing, they all eventually connect to cloud, because that is where everything is. It is just like wherever you go, at the end of the day, if you go up the family tree, you will end up with at the parent. So cloud computing or cloud is like the parent of all these child nodes, and all the resources, full scale is there. And now and then, they all connect to the cloud to be able to provide services. That's what a typical fog computing platform looks like. Highly virtualized, compute, storage, and network between your devices and traditional cloud providers. Typically, but not exclusively, located at the edge of the network. And that is where the distinction comes from, or that is how we are able to distinguish between fog, edge, and mist, as well as cloudlets. The point at which between the device and the cloud where the processing and the computing takes place determines whether it is fog computing, edge computing, mist computing, cloudlets, or mobile computing. So now we are going to look at the characteristics of fog computing in detail. I've already spoken about that. Compute, storage, and network resources. Edge of the network, okay, where the processing takes place, where the computing takes place. The nearer you are to the user, the lower latency you will have. Edge location, location awareness, and low latency. This is the number one characteristic. Second one, geographical distribution. There is a requirement to have your fog nodes all over the place, so that wherever the user is, he or she can find a nearby fog node to connect to and continue computing in the fog. Okay, so as it says there, in sharp contrast to cloud, which is centralized, fog becomes decentralized, and it gets distributed geographically as much as possible. And one of the requirements is that the user should have a node available, a fog node available nearby, so that he or she can continue computing in the fog. It's just like, whenever we go out, we are looking for the nearest Wi-Fi spot or hotspot to be able to connect to the internet. Fog nodes are the same. You have to distribute it far and wide. And the second bullet point, nowadays, I'm not sure whether you have experienced it or not, but nowadays you can get access to internet if you are inside your car, if you are inside buses, if you are inside trains, or wherever you are. And maybe not in Fiji, but in other countries, you will see that there is this fog nodes, internet antennas, and all these things on top of cars, trains, buses. And as people are traveling, they are able to get access. Large-scale sensor networks is another characteristic of fog computing. Again, if you look at the technology applied here, or the concept applied here, we are looking at smart cities, smart grid, to monitor the environment, monitor energy consumption, monitor traffic, monitor weather, monitor what is going on, monitor breakdowns, traffic lights. So these large sensor networks, they provide information and data to a centralized server, and then people make decisions. Very large number of nodes, okay, similar to geographical distribution. You have a wide geographical distribution, you will have very large number of nodes, and they will be in a smart grid. Support for mobility, that is especially for mobile devices, wherever you are or wherever you go, and as you move geographically, as you move within the city, or as you move within the campus, you are able to have a seamless usage of fog computing, because as you move along, you will find a fog node near you and you are able to connect. Real-time interactions, okay, and this is one of the reasons why fog computing exists, to provide real-time data, real-time streaming, time-sensitive data, and latency-sensitive applications. So it's not batch processing. It's your request needs to be attended to, entertained, and responded to immediately. Wireless access and fog nodes can come in different form factors, and will be deployed in a wide variety of environments. And I've already mentioned a few, for example, Internet of Things, smart cities, smart grid, and whatever else you have out there. Interoperability and freedom, okay. For components, fog nodes, and any apps that run on the fog computing platform must be compatible and must be able to operate across various platforms and services. And streaming is a good example. For example, wherever you are, and if you are streaming anything live, or if you are streaming a live soccer match or a rugby match, wherever you go, if you are connected to one of the fog nodes, you'll be able to stream. Big data interactions and interplay between the fog, the cloud, and big data mining and big data analytics. Because your fog, first of all, your mobile devices collect huge amounts of data. And then your fog computing nodes collect huge amounts of data. And they all feed. So your mobile devices feed this data into fog computing feeds this data into cloud computing, and the amount of data it has got, if you do data mining on that and if you do big data analytics, you will get some useful information and intelligence. Looking at fog computing players, the providers and the users. So fog computing is still in its early stage. I mean, cloud computing came in around 2012. Fog computing came in around 2014, 2015. So this technology is very young, let's say in its infancy or just in its inception, 3-4 years old. So at this moment, it is we cannot determine how different fog computing players will align, but the expectation is that they will follow the cloud computing model, and alignments will be similar to the ones that happens within the cloud computing platform. So it is anticipated that subscriber models will play a major role in the fog, infotainment in connected vehicles. Okay, I mean, in time to come, at the moment, some of the places where I have used public transportation, like buses, trains, were able to provide live TV broadcasts and things like that. But in time to come, that will be available in almost all public transportation, and you will be able to, apart from that, you will be able to stream live events onto your mobile phones. Connected vehicles, driverless cars, smart grids, smart cities, healthcare, and so forth. New forms of competition and cooperation between providers angling to provide global services. New industries, new incumbents will enter the era of fog computing. New genre of users, new breed of users, new types of providers that will be providing you utilities. I mean, nowadays you can already get your utilities metered. You can pay for whatever you are using, or you can prepay for your utilities. Smart vehicles, car manufacturers, in time to come, your car would be able to communicate with sensors that are placed on the road, and these sensors will provide information. Your car will be able to communicate with sensors with the car in front of you, and it will warn you if you are going too close or if you are about to have accident. It will warn you, and there is also talk about it going on autopilot and trying to decrease the speed of your car and so forth. Public administration, smart cities, smart citizens, government to citizen services, and transportation. I mean, it's heavily used in transportation, congestion, collision avoidance, and so forth. So we look at fog computing versus cloud computing. Cloud computing is quite efficient and proficient, lots of productivity, but when we compare, this is what we get. So with fog computing, there is low latency, that is our requests for services and our the response for services comes very fast. Delay is very high with cloud computing, low with fog computing. Location of service within the internet at the end of the cloud computing service provider's server, with fog computing at the edge of the local network. Distance between client and server, multiple hops with cloud computing because it's far away. With fog computing, it is one hop only. Security of cloud computing is undefined, so security issues for fog computing, you can define it. Attack on data on the way, high probability because your data travels through several hops, through several nodes, through several routers before getting to the cloud computing service provider. But with fog computing, it is very low probability because your data just travels very nearby and you are able to secure it. Cloud computing has no location awareness. Fog computing has. Cloud computing is centralized. Fog computing is distributed. Number of server nodes with cloud computing is few. With fog computing, it has to be very large. Support for mobility with cloud computing is limited. With fog computing, it is supported that you can be as mobile as possible, nomadic as possible. Real-time interactions, both of them support. Last mile of connectivity with cloud computing, you are either doing a fiber optics network or a leased LAN or a cable network or something. With fog computing, the last mile is wireless and mostly wireless. So what happens with data and applications? They are processed in the cloud, which is time consuming for large data. Fog computing, rather than presenting and working from the centralized cloud, fog operates on edge of the network, so it consumes less time. Cloud computing, problem of bandwidth. Fog computing, less demand for bandwidth. Cloud computing, slow response time, scalability problems, because the servers are not distributed or located in remote places. But with fog computing, you can set up all those nodes and edge servers, and you should be able to connect to one of that, and there's visibility of users, and the low latency continues. Next, we'll compare fog computing and edge computing. So both of them push processing, computing, intelligence near towards the user and the user's devices. So the difference between the two is where exactly that happens. And most researchers say, and most research publications state that with the fog computing, it takes place at the edge of the network, the outer edge of the network, and with the edge computing, it takes place near the user's devices. So if you look at the graphic there, you have thousands of cloud data centers, millions of fog nodes, and billions of edge devices. And they all connect to each other because at the end of the day, the main processing capacity is in the cloud. And these edge devices, they process whatever they can within the inner edge of the network, and they communicate to the fog nodes on the outer edge of the network, and they in turn communicate to cloud data centers. So edge computing pushes processing, computing, intelligence right to the devices, right to the PLCs, right to the appliances. Whereas fog computing pushes it to the outer edge of the network. And this is another look at that. Fog nodes, and then on your extreme left-hand side, all those devices, edge computing devices. And yeah, that's it. So I'm going to stop this share and check if you have any questions. There's something on the chat. Oh my God. Shivanas, you are chatting to everyone? You know, you can do private chat to only the person you want to chat to. So now I know that you are on sick leave. And I will tell your boss. Okay, all right. Yes, Melvin, epic fail. All right, so last 5 minutes. Any questions or comments? Really, no one? If you are feeling shy, you can chat the question to me.
All good, sir.
All good?
Yes, sir.
Salmendra, okay, thank you.
Thank you.
Yeah, thank you, Atama. No questions. You can slowly start leaving. Start leaving the meeting. I'll be around for another 5 minutes in case anyone has any question or people want to ask when others are gone.
All right, sir. See you next
All
week.
right, thank you. Yeah, time to go. All right, yeah, send me an email, no problem. The remaining students, any questions?